The database is a vital part of any software product. There are so many databases available in this era. Many organizations are offering a database as a service. One of the giants is Google Cloud Platform, as it is rich in services and features. Through the use of databases in Google Cloud Platform, deployments and migrations becomes accelerating, as well as the management of operational and analytical data becomes official. Hello everyone, this is Dhruv from Edureka and I welcome you all to this session where I will be talking about GCP Database Services. So without any further ado, let's take a look at today's agenda. We will start this session by first having an overview of Google Cloud Platform as well as of a database. And then we will understand the different types of databases and the services they provide. We will also look into the solutions provided by GCP databases and different techniques to deploy them. And then finally, we will deploy a GCP database service hands-on. So first, let's get an overview of the Google Cloud Platform. Offered by Google, it is a suite of cloud computing services that runs on the same infrastructure that Google uses internally in its end-user products, such as Google's search engine, Gmail, file storage, and YouTube. Along with a set of management tools, it provides a series of modular cloud services, including computing, data storage, data analytics, and machine learning. For organizations with large amount of data to store or analyze, Google Cloud Storage prices are up 20% cheaper than AWS, and the price of database services also compares favorably. While there is no difference in the price of container services, Google Cloud is an industry leader in the field and is also investing heavily in AI and machine learning technologies. Many small and large enterprises are increasingly adopting Google Cloud Platform, which bodes well since it disengages things and makes them more secure at reasonable cost. Now let's have an introduction of database. First, let's understand why do we need a database. A good database is crucial to any company or organization. This is because the database stores all the pertinent details about the company, such as employee records, transactional records, salary details, etc. The various reasons a database is important are: it manages large amounts of data. A database stores and manages a large amount of data on a daily basis actually. This would not be possible using any other tools such as a spreadsheet, as they would simply not work. Second, its accuracy. A database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in a database is guaranteed to be correct in most cases. Third, it's easy to update. So in a database, it is easy to update data using various data manipulation languages available. One of these languages is SQL. Fourth, the security of data. So databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. Fifth is data integrity. So this is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. Last one, that is easy to research database. So if you see, like, it's very easy to research and access the data in database. This is done using a data query language, which allows searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data and the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just database. Data within the most common types of databases in our operation today is typically modeled in rows and columns. In a series of tables to make processing and data querying efficient, the data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases uses structured query language, means SQL, for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Examples include computerized library systems, flight reservation systems, or computerized parts inventory system, and many content management systems that store websites as collections of web pages in a database. Now that you have an overview of Google Cloud Platform as well as of a database, now let's understand the different types of GCP databases. So the first is relational databases. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. Columns of the table hold attributes of the data, and each record usually has a value of each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. Relations that store data are called base relations, and in implementations are called tables. Other relations do not store data, but are computed by applying relational operations to other relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key, this being a consequence of a relation being a set. A primary key uniquely specifies a tuple within a table. While natural attributes, I mean attributes used to describe the data being entered, are sometimes good primary keys. A foreign key is also there in a relational database management system. So a foreign key is a field in a relational data table that matches the primary key column of another table. It relates the two keys. Foreign keys need not have unique values in the referencing relation. A foreign key can be used to cross-reference tables, and it effectively uses the values of attributes in the reference relation to restrict the domain of one or more attributes in the referencing relation. Second is key value databases. So a key value database or key value store is a data storage paradigm designed for storing, retrieving, and managing associative arrays, and a data structure more commonly known today as a dictionary or hash table. Dictionaries contain a collection of objects or records which in turn have many different fields within them, each containing data. Okay, so these records are stored and retrieved using a key that uniquely identifies the record and is used to find the data within the database. So key value databases work in very different fashion from the better known relational databases. Relational databases predefine the data structure in the database as a series of tables containing fields with well-defined data types. Exposing the data types to the database program allows it to apply a number of optimizations. In contrast, key value system treats the data as a single opaque collection which may have different fields for every record. This offers considerable flexibility and more closely follows modern concepts like object-oriented programming. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads performance. A lack of standardization and other issues limited key value systems to niche uses for many years. But the rapid move to cloud computing after 2010 has led to a renaissance as part of the broader NoSQL movement. Now, the third one is document database. So, a document-oriented database or document store is a computer program and data storage system designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data. Document-oriented databases are one of the main categories of NoSQL databases, and the popularity of term document-oriented database has grown with the use of the term NoSQL itself. XML databases are a subclass of document-oriented databases that are optimized to work with XML documents. Graph databases are similar but add another layer, the relationship, which allows them to link documents for rapid traversal. Document-oriented databases are like inherently a subclass of the key value store, another NoSQL database concept. So the difference lies in the way the data is processed. In a key value, the data is considered to be inherently opaque to the database, whereas the document-oriented system relies on internal structure in the document in order to extract metadata that the database engine uses for further optimization. Although the difference is often negligible due to tools in the systems, conceptually, the document store is designed to offer a richer experience with modern programming techniques. So, document databases contrast strongly with the traditional relational database. Like relational databases generally store data in separate tables that are defined by the programmer, and a single object may be spread across several tables. So document databases store all information for a given object in a single instance in the database, and a very stored object can be different from every other. This eliminates the need for object relational mapping while loading data in the database. So the fourth we have is in-memory database. And in-memory database, IMDb, also a main memory database system, or MMDB, you can say it like a memory resident database, is a database management system that primarily relies on main memory of a computer data storage. It is contrasted with the database management systems that employ a disk storage mechanism. So in-memory databases are like faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are like simpler and execute fewer CPU instructions. So accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. Applications where response time is critical, such as those running telecommunication, network equipment, and mobile advertising networks, often main memory databases. So, in-memory databases have gained much traction, especially in the data analytics space, started in the mid 2000s, mainly due to multi-core processors that can address large memory and due to less expensive RAM. A potential technical hurdle with in-memory data storage is the volatility of RAM. So specifically in the event of a power loss, intentional or otherwise, data stored in the volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Now the last one is additional NoSQL databases. Like a NoSQL database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in the relational databases. So there are additional NoSQL databases present in GCP like MongoDB and others. So now that you have understood the types of databases, let's now understand services under these types of databases. So first we have relational databases, under which we have Cloud SQL and Cloud Spanner. So Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational MySQL databases on cloud platform. The Cloud SQL for MySQL connector allows you to access data from Cloud SQL for MySQL databases within Data Studio. So its key features are like fast and easy migration. So database migration service makes it easy to migrate databases from on-premises compute engine and other cloud to Cloud SQL with minimal downtime. So second is secure access and connectivity. So Cloud SQL data is encrypted when on Google's internal networks and when stored in database tables or temporary files and backups. So Cloud SQL supports private connectivity with virtual private cloud. And every Cloud SQL instance includes a network firewall allowing you to control public network access to your database instance. Third is easy integration. So access Cloud SQL instance from just about any application. Easily connect from App Engine, Compute Engine, Google Kubernetes Engine, and your workstation. Open up analytics possibilities by using BigQuery to directly query your Cloud SQL databases. Then fourth is the standard APIs. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and SQL Server databases, ensuring application compatibility. So use standard connections drivers and build migration tools to get started quickly. Then fifth is application compatibility. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and Microsoft SQL Server databases, ensuring application compatibility. Then the last one is automatic storage increment. So Cloud SQL can automatically scale up storage capacity when you are near your limit. This way you don't have to spend time estimating future storage needs or spend money on capacity until you need it. Now the question is when to choose Cloud SQL. From lift and shift of on-premise SQL databases to the cloud to handling large-scale SQL data analytics to supporting CMS data storage and scalability and deployment of microservices, Cloud SQL has many uses and is a better option when you need relational databases capabilities but don't need storage capacity over 10 TB. I mean 10 terabytes. Now coming to Cloud Spanner. So Spanner is a distributed SQL database developed by Google. Spanner is a globally distributed database service and storage solution. It provides features such as global transactions, strongly consistent reads, and automatic multi-site replication and failover. Its key features are first, auto sharding. Cloud Spanner optimizes performance by automatically sharding the databases on request load and size of the data. As a result, you can spend less time worrying about how to scale your database and instead focus on scaling your business. So second is it is fully managed, which means easy deployment at every stage and for any size databases. Synchronous replication also synchronous replication and maintenance are automatic and built in. The third one is it has regional and multi-regional configurations. No matter where your users may be, apps backed by Cloud Spanner can read and write up-to-date, strongly consistent data globally. Additionally, when running a multi-region instance, your database is able to survive a regional failure and offers industry-leading 99.99% availability. So fourth is built on Google Cloud Network. Cloud Spanner is built on Google's dedicated network that provides low latency, security, and reliability for serving users across the globe. Fifth is it provides multi-language support. So client libraries in C, C++, Go, Java, Node.js, PHP, Python, and Ruby, JDBC drivers for connectivity with popular third-party tools. Last is backup and restore. Backup and restore recovers the database to the last state when the backup or the export was taken. PITR provides continuous data protection with the ability to recover your past data to a microsecond granularity. Now the question is when to choose Cloud Spanner. So Cloud Spanner should be your go-to option if you plan on using large amounts of data, more than 10 terabyte, and need transactional consistency. It is also a perfect choice if you wish to use sharding for higher throughput and accessibility. Now the next is a key value database, under which Google provides Bigtable service. So Bigtable is a compressed high-performance proprietary data storage system built on Google File System, 𝐶𝐵 log service, SST table, and a few other Google technologies. Some of its key features are: it is built for use cases such as personalization, edtech, fintech, digital media, and IoT. Second is it gives better prediction. Designed with a storage engine for machine learning applications, leading to better prediction. Third is high throughput at low latency. So Bigtable is ideal for storing very large amounts of data in a key value store and supports high read and write throughput at low latency for fast access to large amounts of data. Throughput scales linearly. You can increase QPS, means queries per second, by adding Bigtable nodes. So Bigtable is built with proven infrastructure that powers Google products used by billions such as search and maps. Then fourth is the cluster resizing without downtime. It scales seamlessly from thousands to millions of reads or writes per second. Bigtable throughput can be dynamically adjusted by adding or removing cluster nodes without restarting, meaning you can increase the size of a Bigtable cluster for a few hours to handle a large load, then reduce the cluster size again, all without any downtime. Like, it's flexible and automatic replication to optimize any workload. So write data once and automatically replicate where needed with eventual consistency, giving you control for high availability and isolation of read and write workloads. No manual steps needed to ensure consistency or repair data or synchronize writes and deletes. Benefit from a high availability SLA of 99.999% for instances with multi-cluster routing across 3 or more regions, 99.9% for single cluster instances. So next is like it easily connect to Google Cloud services such as BigQuery or the Apache ecosystem. Last is it seamlessly scaled to match your storage needs, so no downtime during reconfiguration. Now the question is when to choose Bigtable. So Cloud Bigtable is a good option if you are using large amounts of single key data and is preferable for low latency, high throughput workloads. Moving on to the next type of services, that is document database services, under which we have Cloud Firestore and Firebase. So Cloud Firestore is a cloud hosted NoSQL database that your iOS, Android, and web apps can access directly via native SDKs. Cloud Firestore is also available in native Node.js, Java, Python, Unity, C++, and Go SDKs in addition to REST and RPC APIs. It is a flexible, scalable database for mobile, web, app, and server development from Firebase and Google Cloud. Some of its key features are: first of all, it is serverless, which helps you in focusing on your applications development using a fully managed serverless database that effortlessly scales up or down to meet any demand with no maintenance windows or downtime. Second is live synchronization and offline mode. Built-in live synchronization and offline mode makes it easy to build multi-user collaborative applications on mobile web and IoT devices, including workloads consisting of live asset tracking, activity tracking, real-time analytics, media, and product catalogs, communications, social user profiles, and gaming leaderboards. Third is powerful query engine. Firestore allows you to run sophisticated ACID transactions against your document data. This gives you more flexibility in the way you structure your data. Fourth is libraries for popular languages. Focus on your application development using Firestore client-side development by libraries for web, iOS, Android, Flutter, C++, and Unity. So Firestore also supports traditional server-side development libraries using Node.js, Java, Go, Ruby, and PHP. Fifth is security. The Firestore seamlessly integrates with Firebase authentication and identity platform to enable customizable identity-based security, access controls, and enables data validation via a configuration language. So the last one is data store mode. Firestore supports the data store API. You won't need to make any changes to your existing data store apps, and you can expect the same performance characteristics and pricing with the added benefit of strong consistency. Existing cloud data store databases will be automatically upgraded to Firestore in the next year of 2022 also. So now the question is when to choose Firestore. When your focus lie on app development and you need live synchronization and offline support. Now coming to Firebase real-time database. Over the last few years, Firebase has grown to become Google's app development platform. It now has 16 products to build and grow your app. If you have used Firebase before, you know it already offers a database which is the Firebase real-time database. So the Firebase real-time database with its client SDKs and real-time capabilities is all about making app development faster and easier Since its launch, it has been adopted by hundreds of thousands of developers, and as its adoption grew, so did usage patterns. Let's discuss some of its key features. So, first of all, it provides real-time synchronization for JSON data. So, developers began using the real-time database for more complex data and to build bigger apps, pushing the limits of the JSON data model and the performance of the database at scale. The Firebase Real-Time Database is a cloud-hosted NoSQL database that lets you store and synchronize data between your users in real time. In its new update, Cloud Firestore enables you to store, synchronize, and query app data at global scale. Second is like collaborate across devices with ease. So real-time synchronization makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Third is build serverless apps. So real-time database ships with mobile and web SDKs, so you can build applications without the need of servers. You can also execute backend code that responds to events triggered by your database using cloud functions for Firebase. Fourth is optimized for online use. So when users go offline, the real-time database SDKs use local cache on the device to serve and store changes. When the devices come online, the local data is automatically synchronized. And the last one is strong user-based security. The real-time database integrates with Firebase authentication to provide simple and intuitive authentication for developers. You can use Google's declarative security model to allow access based on user identity or with pattern matching on your data. So the use cases for Firebase real-time database involve development of applications that work across devices, advertisement optimization and personalization, and third-party payment processing. Now moving on to the next type of service, that is in-memory database services, under which Google provides memory store. So memory store reduces latency with scalable, secure, and highly available in-memory service for Redis and Memcached. Memory store automates complex tasks for open source Redis and Memcached, like enabling high availability, failover, patching, monitoring, so you can spend more time coding. Start with the lowest and smallest size and then grow your instance with minimal impact. Memory store for Memcached can support clusters as large as 5 terabytes, supporting millions of QPs at very low latency. So memory store for Redis instances are replicated across two zones and provide a 99.9% availability SLA. Instances are monitored constantly and with automatic failover. Applications experience minimal disruption. Some of its key features are choice of engines. So choose from the two most popular open source caching engines to build your applications. Memory store supports both Redis and Memcached and is fully protocol compatible. Choose the right engine that fits your cost and availability requirements. Second is security. So memory store is protected from the internet using virtual private cloud networks and private IP, and comes with the IAM integration, all designed to protect your data. Systems are monitored 24/7 and 365 days, ensuring your applications and data are protected. Third is it's fully managed. So provisioning, replication, failover, and patching are all automated, which drastically reduces the time you spend doing DevOps. Fourth is monitoring. So monitor your instance and set up custom alerts with cloud monitoring. You can also integrate with the open census to get more insights to client-side metrics. Fifth is it's highly available. So standard tier memory store for Redis instances provide a 99.9% availability SLA with automatic failover to ensure that your instance is highly available. You also get the same availability SLA for Memcached instances. Last is migration. So memory store is compatible with open source protocol, which makes it easy to switch your applications with no code changes. You can leverage the import and export feature to migrate your Redis and Memcached instance to Google Cloud. Now the question is when to choose a memory store. If you are using key value datasets and your main focus is transaction latency, then you can go for memory store. Now moving on to the last type of database services, that is additional NoSQL database services, under which we have MongoDB Atlas and Google Cloud Partner Services. So MongoDB is a source available cross-platform document-oriented database program classified as a NoSQL database program. MongoDB uses JSON-like documents with optional schemes, and MongoDB Atlas is the best way to deploy, manage, and grow MongoDB on Google Cloud. Engineered and run by the same engineers that build the database, Atlas incorporates best practices developed from supporting thousands of distributed deployments into an easy-to-use, fully automated service that grants you the power and freedom to focus on what really matters, building and optimizing your applications. Its key features are: first, its database operations are automated, as database operations take time, and so MongoDB Atlas lowers your stress by orchestrating the moving parts, deploying clusters in minutes, modifying them on demand with zero downtime, and taking advantage of automated patches. So the second is highly scalable. So add storage, scale up, scale out, or scale down with the push of a button or a simple API call. MongoDB Atlas allows you to easily tweak the dimensions of your deployment with no impact to your applications. Third is comprehensive disaster recovery. So MongoDB Atlas includes an optional fully managed backup service that provides continuous backups with point-in-time recovery. Query your backup snapshots and restore granular datasets in a fraction of the time. Easily restore snapshots to different projects to rapidly spin up developer or test environments. Fourth, it's highly available backed by uptime SLAs. Each cluster is distributed across the zones in a Google Cloud region, ensuring no single point of failure. Should your primary fail, MongoDB Atlas will automatically trigger the election and failover process with no manual intervention required. Production databases are backed by 99.95 uptime SLA. Fifth is global clusters. So global clusters in MongoDB Atlas allow you to deploy a geographically distributed database that provides low latency, responsive reads and writes to users anywhere with strong data placement controls to satisfy emerging regulations. And the last one is full performance visibility and optimization. So MongoDB Atlas includes optimized dashboards that highlight key historical metrics, view performance in real time, customize alerts, or dig into the details with ease. So built-in tools such as the Performance Advisor highlight flow running queries and suggest indexes to help optimize your database. Now the next we have is Google Cloud Partner Services. So you can choose Google Cloud Partner Service on the basis of regions, specialization, expertise, initiatives, and products. But why work with a Google Cloud partner? So first of all, it's flexible. So Google Cloud's global network means you can work with a Google Cloud partner that best fits your organization's needs. The second is for the knowledge purpose, like collaborate with a partner that has the right industry background to unlock your next level of business growth. And the third and the last one is experience. So have the confidence to tackle your toughest business challenges with the support of a partner with proven success. So one more thing is like Google partners are the ones you can trust actually. So partners that have certified their teams, earned expertise, and achieved specialization have the Google validated skills to help you achieve your goals. So partners are divided in three forms. So first is specialization. So specialization is the highest technical designation a partner can earn. Partners who have achieved a specialization in a solution area have an established Google Cloud Service practice, consistent customer success, and proven technical capabilities vetted by Google and a third-party accessor. Like there is a specialization in application development, cloud migration, data analytics, data management, Internet of Things, machine learning, marketing analytics, etc. Second is expertise. So partners with the expertise designation have demonstrated proficiency and have exhibited customer success through the combination of experience in a specific industry, workload, or product. So for example, like there's an expertise in industry and expertise in Google Cloud product or technology and workload. Third is certification. So partners with teams of Google Cloud certified individuals have the validated technical knowledge and advanced skills to address your business's needs through implementing Google Cloud technologies. There are a lot of certifications like Foundational Digital Cloud Leader, Associate Cloud Engineer, Professional Cloud Architect, Professional Cloud Developer, Professional Data Engineers, and various others. Now let's look at some solutions provided by the GCP database. So the first one is database migration. Database migration is the process of selecting, preparing, extracting, and transforming data and permanently transferring it from one computer storage system to another. With Google Cloud, you can simplify your database migration at every step of your cloud journey. So migrate to Google Cloud databases to run and manage your databases at global scale while optimizing for efficiency and flexibility. There are two database migration strategies. First one is move to the same type of database. So lift and shift databases to Google Cloud using databases like Cloud SQL for MySQL, Cloud SQL for PostgreSQL, Cloud SQL for MySQL Server, Cloud Memory Store for Redis, and Cloud Bigtable, along with Google's open source partner databases like MongoDB, DataStax, Elastic, Neo4j, Influx Data, and Redis Enterprise. Database migration service for Cloud SQL can help to minimize downtime during migration. Second strategy is move to a new type of database. Whether you are moving from proprietary to open source databases or modernizing from traditional databases to scalable cloud native databases, we have a solution for you. Leverage your serverless change data capture and replication service data stream to synchronize data across databases, storage systems, and applications. Google's migration assessment guides and partners can help you get started. Now moving on to the next solution, that is database modernization. So database modernization is primarily about changing applications to work around functional discrepancies between old and new databases. With Google Cloud, you can modernize underlying operational databases to make your apps more secure, reliable, scalable, and easier to manage. Our fully managed solutions reduce complexity and increase agility so you can focus on innovation. So you can upgrade the databases on which your applications are built on by being prepared for growth with quick seamless scaling, which means scale Google Cloud databases seamlessly and build cloud native apps that are prepared to handle seasonal surges or unpredictable growth. Second, move faster and focus on business value, which means enable developers to ship faster and perform less maintenance with database features like serverless management, auto scaling, and deep integrations. And the third one is build more powerful applications with Google Cloud. To transform your business with robust ecosystem of services like Google Kubernetes Engine, easily access data for analytics and AI/ML with BigQuery and Google Cloud AI. So the third database solution is open source databases. An open source database allows users to create a system based on their unique requirements and business needs. It is free and can also be shared. The source code can be modified to match any user preference. So open source databases address the need to analyze data from a growing number of new applications at lower cost. With Google Cloud fully managed, open source database promote innovation without vendor lock-in or high licensing fees. Google Cloud and our partners help you deploy secure open source databases at scale without managing infrastructure. So make the most of Google Cloud's commitment to open source by first line support. So Google provide first line support for open source databases so you can manage and log support tickets from a single window. Second is simple billing. So whether you are using NoSQL or relational databases, you will only see one bill from Google Cloud. Third is a single console. You can provision and manage partner open source database services straight from your Google Cloud console. Now the last major GCP database solution is SQL Server on Google Cloud. So SQL Server is a relational database management system developed by Microsoft. As a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications, which may run either on the same computer or on other computer across a network. Its key features are lift and shift SQL Server. So migrate your existing workloads to Cloud SQL or Cloud Server running on Compute Engine with full compatibility. SQL Server running on Google Cloud works with all of your familiar tools like SSMS and Visual Studio. Connect your existing workloads to the best of what Google Cloud has to offer. Second is reduce operational overhead. So Cloud SQL for SQL Server is a fully managed database service with a 99.95% SLA. Being fully managed includes upgrades, patching, maintenance, backups, and tuning regional availability in various virtual machine shapes with memory from 3.75 GB up to 416 GB and storage up to 30 TB for all workloads. Provide flexible scaling options to eliminate the need to pre-provision or plan capacity before you get started. Now the last one is a live migration for underlying virtual machines. When you run SQL Server on Compute Engine, the virtual machines can live migrate between host systems without rebooting, which keeps your applications running even when host systems require maintenance. Now let's understand the methods of deploying databases on Google Cloud Platform. So GCP predominantly offers three types of reference architecture model for Google data distribution. In that, the first one is single cloud deployment. The simplest of all deployment models, one can deploy databases by creating new cloud databases on Google and or by lift and shift or pre-existing workloads. So the second is hybrid cloud deployment. These types of deployments are useful when one has applications in the cloud that needs to access on-premises databases or vice versa. There are three primary factors to be considered when deploying a hybrid model, with some data on cloud platform and some on premises. So that's why it's been shown like a public cloud and private cloud. And so in primary factors, first one is a master database. First and foremost, you need to decide whether your master database is stored on premises or on the cloud. Once you choose the cloud, GCP resources act as a data hub for on-premises resources, whereas if you choose on-premises, your in-house resources synchronize data to the cloud for remote use or backup. Second is managed services. So available for resources in the cloud, these services comprise scalability, redundancy, and automated backups. You, however, have an option of using third-party managed services. Third is portability. So based on the type of data store you choose, the portability of your data is affected too. To ensure reliable and consistent transfer of data, you need to consider a cross-platform store such as MySQL. So the third kind of deployment is multi-cloud deployment. These types of deployments can help you effectively distribute your database and create multi fail-safes, as it enables you to combine databases deployed on Google Cloud with database services from other cloud providers, thereby giving you an advantage of a wider array of proprietary cloud features. And there are two primary factors to be considered when deploying this model. First is integration. So, ensuring that client systems can seamlessly access databases regardless of the cloud they are deployed on. For instance, use of open source client libraries to make databases smoothly available across clouds. Second is migration. So, since there are multiple cloud providers, one may need to migrate data between clouds with the help of database replication tools or export or import processes. So, Google Storage Transfer Service is one such tool to help you with database migration. Now that you have a theoretical understanding of GCP Database Services, let's now deploy a database service on Google Cloud Platform. So you can just go to search for Google Cloud Platform. Just open this link and go to the console. You can also go to the documents part and you can understand more about the database services quite briefly. But right now, because we are going to demonstrate it practically, let's go to the console. So this is how the Google Cloud Platform console looks like. Also, if you don't have an account on Google Cloud Platform, then create one. Like Google Cloud Platform is a very nice platform to have your account on. You get a free trial in it. Like you can see here, my free trial has like 4711 credits and 23 days left in it. What happens is you get a free trial of 90 days in which you get the 300 US dollars of credit. So you can use that credit like doing the exercise I'm going to explain you in this. Also, like when you create this account, it will just debit 1 rupee and it will also get refunded to you quite soon. So you just have to give your credit and debit card details also for it. Okay, so let's start. You just go to my demo. This place, this demo is just the name of my project. You have to create your own project. You can just go to new project and create your project. Give it a name, and that's it. I have this demo and several other projects, so I will go with demo only. So that's the name of my project. So these are the project name, project ID, project number is given. So what I'm going to explain here today is like this database services Cloud SQL. So Google Cloud SQL service. So where I will be creating an SQL instance and also like the database also I will be creating in it and also a user account. Okay. So you can just go here and go to databases. From here you can go to SQL or you can search from here. Just you can search here SQL. So yeah, we are here. Let's go to SQL. Okay, this is like one of the instance which I have already created. So that's why it's showing like this. But when you open it for the first time, it asks for what kind of instance you want to create, like MySQL or the PostgreSQL or any other. So because I have already created one, so it's not asking me. I will just go and create the instance from here. Yeah, this page you will get. Okay, that's what I was saying from SQL Server, PostgreSQL or MySQL. Okay, so I will be creating MySQL. So you can give a name. One more thing, it should be unique. It should cannot repeat the name of an instance again and again. Okay, so give it a unique name. So I will just give database service demo. Also there should be one number. So yeah, database service demo 1. Okay. Also give the password if you want to, because right now we are just it's demo. So I will choose no password. Also choose the version from here for it. Right now I'm going with MySQL 5.7 only. Also select your region. Like I have this region nearest to you. Like I have region nearest to me is Asia South 1. Also select your zone. So we like Asia South 1. Okay. Also you can like do further customizations. So let's see the machine type. So select whichever is suitable for you. Like right now I don't require quite a high one. Like so I will go for a standard one. But like here we have like in high memory we have 4 virtual CPUs and 26 GB memory or 52 GB memory with 8 virtual CPUs and then 16 virtual CPUs, 104 GB memory. Then you can customize it by yourself also. So you can just give by yourself whatever you wanna select. Okay. But right now I will go with the standard one. So that's more than enough because the more higher the features you will choose, the more it will cost. Okay. So remember that. So I will just remember the standard one virtual CPUs, 3.75 GB, and then you can choose SSD or HDD, whatever you want to choose. So I will just choose 10 GB. It's more than enough for me right now. It was just for demo purpose. So yeah, then we can also go for connections, public, private, whatever IP is there. You can choose for that. Select that. Okay.
and you can then just go to backups, like at what time you want to get your backup. So if you choose the time, yeah, you can select the region also. That's just okay. Multi-region is okay. Then for maintenance purpose, you can like on which day it gets serviced. Okay, for maintenance. So that's it. And also you can select your flag, labels, or whatever you want to choose. Okay, so everything is done now. So let's create the instance. Okay, use lowercase letters. Okay, remember that to use the lowercase letters. Okay, also like use lowercase letters, numbers, and hyphens. Start with a letter. Okay, strings are given. Keep that in mind. So let's create the instance now. So as you can see here, the instance has been created. So here it is, and here you can see the overview of it, like the things are being given. You can see here like the public ID is given, and this is just the CPU utilization it's given. And now right now it's not utilizing, so it's not showing anything. So the configurations are given and everything. One more like suggestion a service account and everything is given. But one cool thing let you know about this instances, you can connect it through Cloud Shell. So just click here. So it's getting connected with Cloud Shell. So 𝐔𝐶loud SQL Connect Database. So it will show here. Just enter, authorize it. It will take some time. A few minutes it will take. Yeah, not more than that. So you can see like it's asking for password, but I haven't created password, so I will just enter. But if you created the password, just enter the password and go for the next step. So now you can see the databases. So just type for it show databases. These are the databases, and if you want to create a database in it, you can just type create database demo, or you can just give test database service. Okay, so yeah, okay, just don't give hyphen or anything like that. Okay, just say create database test. Okay, yeah, so it's got creators. You can just show databases, and you can see here test is being created. Okay, so now you can just exit from here. So exit. So you have to exit again. Now it will be exited from Cloud Shell. Okay, so now you can come to databases. So under database SE demo 1, that's the instance name of our SQL database. So yeah, you can see like this is the name of our SQL instance database SE demo 1. So here you can see like test is also being created. Okay, and also like you can come to users also. Here also default one is the root. So you can create a database from here also. Like just have to click here, create database, give it a name, test 1. Okay, yeah, just create it from here. Similarly, test 1 is created. Okay, similarly you can go to users, you can create a user account with the name group 66. That's it. And give a password also if it's optional, but we can just give one. So 662. Just create. So the user account will be created. Yeah. Okay. That's how users and databases are being created. I hope you have understood it now, how to create it through Cloud Share and everything. That's how the instance are being created through Cloud SQL. Okay. With this, we come to the end of today's session of GCP Database Services. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.